My name is Kiara Fenn. My experiment revolves around this question. How does the magnetic flux density of a surrounding magnetic field affect the height and gravitropism of Wisconsin fast plants? My results did not show any distinct effect on gravitropism, so I focused on how magnets affect plant height. Why should the world care? Well, if it was discovered that magnetic fields do help plants grow, magnets could be used as sustainable alternatives to artificial fertilizers, reducing the risk of toxic runoff and harmful bioaccumulation. Magnetic fields affect plant growth by inducing abiotic stress. Abiotic stress is a group of reactions that a plant puts into effect when it feels threatened by its environment. During abiotic stress, plants produce more proline, which enhances growth in three main ways. Proline provides nitrogen and carbon as a source of energy for plants. Proline also maintains a low ratio of the molecule NADPH to NADP+. This allows more NADPH to be created, allowing photosynthesis to be continued or done faster. Proline provides electrons for the respiratory chain. This induces higher rates of cellular respiration, allowing plants to produce more energy. Basically, I wanted to see if I could help plants grow by stressing them out. My hypothesis states that as the magnetic flux density increases, the height of the plants will increase. The abstract you have summarizes my first experiment, but I just finished repeating that experiment last week. The first time, my results were inconclusive. The second time, the data matched my hypothesis. In both experiments, I tested a control group and 4 different levels of magnetic flux density, ranging from 5,000 to 40,000 Gauss. I had 9 plants for each level, split 3 to a pot. I watered and measured each pot every day for 28 days, except for a 10-day break in the first experiment, during which my family was out of town. I bottom watered for a fixed amount of time in the first experiment, but top watered with a specific amount of water in the second. In the second experiment, I used a homemade T-square that rested on the edge of the pots to measure the height of the plants. This reduced the possible errors created when a ruler from the first experiment sank into the soil. Half of the data from the first experiment supported my hypothesis. The majority of the plants surrounded by a magnetic field grew taller than the control plants until day 13. The other half disputed my hypothesis, making the results inconclusive. The data did, however, suggest that stronger magnetic flux densities induce faster germination rates. All of the plants in the second experiment sprouted at around the same time, and, unlike the first experiment, the results generally matched my hypothesis. The data also showed that as the magnetic field flux density increases, the rate of plant growth increases.